Okay, then let's get started. Welcome to our review meeting today. We look at the 1.1.7 release. And here's the agenda. We will start with Axel, who will present the single stack IPv4 to the dual stack IPv4 v6 migration. Then we have two topics from Oliver. First about the SPDY support for the L7 load balancing feature. And then the second topic is about the care controller for extension resources. And then we have Hendrik, who has optimized the processing throughput in Machine Controller Manager. And the last topic from Dominic, we have to shift to next occurrence, unfortunately, because he's on sick leave. So we will do it then in 2 weeks. Okay, with this, then let's get started with Axel and the first topic.
Yeah, hi. I will just share. So, first topic is this PR. We want to enable a migration path from a single stack IPv4 cluster to a dual stack IPv4, IPv6 cluster. Yeah, since we have now IPv6 and IPv6, IPv4 dual stack networking shoots, we also want to have a way to transform or to migrate a shoot from IPv4 to this dual stack cluster. Since, if we don't have such a path, I think some shoots will never have a chance to have IPv6 support. If we just change the IP family or add IPv6 as IP family to the shoot, that will result in a networking outage. The cluster will be broken until everything is reconciled and all nodes are rolled. And I think the node rollout is a major issue also for bigger clusters that don't want to roll all node at a time or do it in a very controlled manner. So we provide here a way to migrate with a controlled node rollout. I think I will just start with the demo since there will be a little bit of time in between. I already prepared a shoot. It's an IPv4 shoot. That's window. We have here the IP families. It's just one IP family, IPv4. And if we look at the resources in AWS, we don't have any IPv6 addresses in the VPC, in the subnets, and also the nodes don't have an IPv6 address. So now I just added my config and add the IPv6 here. The shoot will immediately reconcile. It will now reconcile also the infrastructure, and we will already get IPv6 addresses in the subnet and VPC. Yeah, it's already there. So that's the infrastructure that already is reconciled. And we also see here that we get the AWS IPAM controller that assigns the IPv6 addresses or the new CIDR ranges to the nodes. We introduced a new constraint here. Constraint, and it's this one. The type is dual stack nodes migration ready. With that, we indicate that the nodes are not yet migrated to dual stack. I could have shown that here we have the nodes, and it's still only IPv4. We don't have an IPv6 address here. Yeah, as long as this constraint is set, we actually don't configure the networking the network extension for IPv6, and we don't configure the control plane. For example, the Cube API servers or the Cube controller manager, they're all just IPv4 right now. So let's start to roll the nodes. In a real setup, we would this would be done probably together with a Kubernetes update where the nodes are rolled. I will just delete the nodes and the machines so that they are recreated. So this will take a little bit of time now. What I can also show is that we have introduced the new field in the status of the network resource. And in the status, we also show the IP families that are really deployed in the cluster. So we have, right now, we have only IPv4. We use this field later on to detect if the migration is finished. So if the networking resource shows that it has both IP families, we know that the cluster is really dual stack. Let's look how the machines look like now. Still working. I also added a little bit of documentation how the migration process will work. So the first step is actually, I've already done that, update the IP families in the shoot spec. And as I have shown already, this triggers an infrastructure reconciliation. And it also updates the control plane components of the infrastructure. In our case, that's the IPAM controller. And yeah, now we are doing step 4, the node rollout. And at the end, we will need a final reconciliation to configure all control plane components and the network extension for IPv6. Yeah, our nodes are reconciled. In this case, I have to trigger another reconciliation with the Kubernetes update. We would have already done that, and we would have already detected that all nodes are migrated. In this case, we need to just trigger this reconciliation so that we see this in our constraint. So where is it? The dual stack migration ready is now true. That indicates that the nodes are migrated. Just look at the instances. Just reload. So now we have an IPv6 address. We can also look at the nodes. And the important thing here is that, so where is it? We have the pod sitters here, and we have a pod sitter for IPv6 where the the pod IPs are allocated from. Yeah, now I have to trigger another reconciliation so that the actual migration is done. I'm already a little bit over time, I see. So now I'm the new Kube API servers are deployed. They have now the IPv6 service range. Maybe you can already, if you have some questions, ask them now, since this reconciliation is taking a bit of time. Not very much, but still. So Kube API servers are restarted. Let's see the network resource. We have 2 IP families now in the status. Calico node is starting with the new configuration. I think we can already see the constraint. Yeah, constraint is gone. Yeah, I would say the shoot is migrated successfully. It takes some time until I think what's missing, I don't know. But I think we can stop here.
Yeah, thanks.
Any question?
Very nice. No questions so far? Okay. All right. Thanks, Axel.
Thank you.
Then over to Oliver for the next topic, SPDY support for L7 load balancing.
Hello, good morning. Yeah, today I have 2 topics for you. First one here is the SPDY support for the layer 7 load balancing. Some releases ago, I presented the layer 7 load balancing, and it was enabled or with a different pull request. And when I presented it, I mentioned a restriction for it. And the restriction was that the layer 7 load balancing is working for Kubernetes 1.31 and higher only. The reason for it was that there's the SPDY protocol for streaming APIs like port forwarding, and this SPDY protocol is not supported by Envoy, or it appeared that it was not supported by Envoy. And since Kubernetes 1.31, Kubernetes starts to migrate to WebSockets, and WebSockets are supported. So that's why we enabled it for 1.31. And we had some hiccups here and there. So one major or one big point here was that the Kubernetes conformance tests still require SPDY until Kubernetes 1.33. and yeah, and we want to stay conformant to those tests. So that was not ideal. And additionally, we found out in some of our own implementations that we might have to adapt things in order to migrate to WebSockets when this layer 7 load balancing was activated. And this could be the same for our customers, and it would be a smoother transition if we just stick to the Kubernetes release cycle here. And yeah, that's why that's the story behind this pull request. So we thought it might be a good idea to check whether SPDY could be supported by Envoy, and we found out that's the case. And yeah, I implemented it for Gartner for the 1.117 release, and by doing that, I also removed the restriction here. So Kubernetes layer 7 load balancing is now also available for Kubernetes versions smaller than 131. Okay, that was kind of an introduction. I prepared a demo for it, and unfortunately it started to when I upgraded my setup, it immediately started to reconcile the cluster. I think I was fast enough to stop the guardlet from destroying my my demo. Yeah, so let's see if it's working. So you see here two shoots, local and local 2. The local shoot has a recent Kubernetes version, and the local 2 has an old Kubernetes version. Yeah, it was just created. As I said, it started reconciling, but I killed the Gardenlet when it started, and so the Gardener version should not be is not 117, but 1.116.2. Okay, and I talked about this restriction that we enable Kubernetes layer 7 load balancing only for Kubernetes 131 and higher, and there's a way to check this. And the easiest way is to check the Istio gateway. And when you check the gateway here for the local, for the 132 suit, you see here it's HTTPS protocol. And when we do the same thing for the other shoot, you see it's the TLS protocol. So basically, the first shoot is using layer 7 load balancing. The other one is using the, let's say, traditional layer 4 load balancing. And now we can try to use the streaming protocol for it. When you do so, let's start with a new version. So I just do a port forwarding to the metric server with some debugging infos, and you see when you use this one, it's using the WebSocket protocol for establishing the connection, and in the end the connection are many debugging messages. In the end, the connection is working. Okay, and that's so far so good. But you might also want to access Kubernetes cluster with an older kubectl, like here, 128. That's It's very old, but let's do it here for the demo. So I try to use the port forwarding for with this old version, and this old version is for the as it is 128. It does not support the WebSocket protocol, and you see here, oops, an error message. It tries to use the SPDY protocol. You see it somewhere. I don't. I can. Where is it? I don't see it here. That had me kind of blind. No, I don't see it in the old version. Okay. So it's not working, and that's the typical message is here, the forbidden message when it tries to upgrade the connection. And the same when we try this on the old on the chute with the 128, both should work. So here you see the new kubectl supports SPDY. It first tries to use WebSocket, but this does not work, and then it uses SPDY. So this is working, but this is the layer 4 load balancing. That's really not a surprise. The thing is, we want with the new PR, we want to fix here this problem, that you can use an older kubectl version which does not support WebSockets for chute, and we want to enable the layer 7 load balancing for this chute. Okay, I try to enable Gardenlet again, that the chutes can be finally reconciled. And maybe you can check the gateways. We see here now also the second gateway switch to HTTPS. So layer 7 load balancing is also enabled for the 128 chute. And here we still have HTTPS. So and now, as we are now running on Gardener 117, everything should work. Let's see, I didn't test it before. Okay, switch back to the kubeconfig. I first try to do the regular port forwarding using the new version, and we see here it's still working. I'm wondering why there's here upgrade to WebSocket. The connection is working, and it's using the WebSocket protocol. And the critical path before was the kubectl 128, and this is now also working using the SPDY protocol. And the same things should be here the case. So it port forwarding works with the 132 kubectl client using the SPDY protocol, and it's working for the old one also with the SPDY protocol, because the 128 kube API server doesn't support WebSockets yet. And that's it basically. And with this, we should pass the conformance tests, and additionally, the implementations which rely on SPDY should still work when we enable the layer 7 load balancing feature gate. Okay, yeah, that's it. I think I'm a bit over time, but I have another topic, and I'm gonna be faster on this one.
No problem. We have enough time today.
Okay, so let's switch to the next topic. That's the extension care controller. You might know this extension story, which is, by the way, finished by now, where we introduce the extension object that we can deploy extensions via Garden operator. And one of the last steps here was creating an extension care controller. And extension care controller is doing similar things than other care controllers like shoot care controller, garden care controller, or whatsoever. It checks the status of items which are managed by the extension, and sets according conditions. And there are 3 conditions here, and those 3 conditions are also explained here in the docs, Garden docs concepts operator. So we have the controller installations healthy conditions, which checks the controller installations belonging to this extension. We have runtime healthy, and that's checking the conditions of the managed resource, which apply the components of the extension deployed in the runtime cluster, and the admission healthy condition, which is doing the same for the managed resources for the admission webhook. Okay, there's a short demo for it, and I think this is really short, using the same setup. So here you see the extension for provider local, which we also always deploy, and you see the conditions of these extensions, this extension, and here we find some of the conditions I mentioned. That's the controller installations. That's the reason that it's not the condition. Here, that's the condition. Controller installation. Oops. Runtime healthy. And also admission healthy. So these 3 conditions are there. And now we can try to play around and see whether they react. Let's start with the first one, maybe this one. Let's start here with the controller installations. Okay, yeah. The namespace changed meanwhile. Okay. We see here now it's reacting. Controller installation is unhealthy because the deployment, there's something wrong with the deployment. It's fixed again, but I think you've seen it. Next thing could be not the gardenlet, but looking for this runtime. Then this runtime extension here, this one. The runtime components are also reacting. And the last part of the story is not gardenlet, but the admission controller. And also this condition is reacting when I scale down the corresponding deployment. Yeah, that's already it for the demo. Do you have any questions?
So will it reflect in the dashboard as well?
I think the dashboard is not adapted yet. Yeah.
The dashboard generally does not show the garden or extension resources at the moment, but I think it's in their backlog at least. So at some point in time, it will not only show the shoots, but hopefully also the seeds and the garden and so on.
Okay, thanks.
Okay, then if there are no other questions, thanks, Oliver, for the two presentations. And we can hand it over to Hendrik for the last topic for today, the machine controller manager processing throughput.
Okay, thanks. Okay, so this PR is kind of a result of a small murder mystery that we tried to solve in recent days. The starting point was a stakeholder complaining or reporting that their shoot reconciliation is running for several hours and not finishing. And when we started checking, we figured out that the machine controller manager pod was frequently recreated, and that was a little bit strange. In the result, the machine controller manager did not finish its processing of all machine deployment objects, and thus the reconciliation was stuck. But figuring out why the MCM got deleted was a little bit tricky. So the usual suspects were not responsible for that. So there were no VPA evictions, there were no node drains, there was no scaling or reconfiguring of MCM. So the replica set hash stayed the same all the time. And only when we enabled access logging on the SeedsCube API server, we found at least a user agent pointing to the AWS extension in this case. And then finally we were able to find error messages that looked a little bit like this. So the worker controller said it deleted the MCM manager, the MCM pod, because it deemed it stuck. And upon digging further, we found this piece of somewhat ancient code that runs a function that checks if the machine controller is considered to be stuck. It has an arbitrary time mode of 2 minutes. So that might be something that we can have a look at in a second step and figure out whether this is still needed. But essentially, the check runs over all machine deployments and checks whether there are machine sets for those, and if they have been processed. And in this particular case, we had I think around about 400 machine deployments. MCM was just not fast enough to process all of them, and then ran into this 2-minute stuck threshold and got terminated over and over and over again. Upon digging further, we found that we currently ran the machine controller manager with its default configuration. So that was before the PR. So we had no specification for its throughput. And by default, the machine controller manager just runs with 20 QPS and a burst of 30, which is fairly low if we compare it to components like VPA and so on. And that's the point where we try to tune that a little bit. So we did some experiments with the test setup of the stakeholder, and that seemed to work. So in the end, the suggestion was to increase the QPS and burst significantly. And rolling that out should help. Also processing larger machine deployments or worker pool configurations where people have lots and lots of worker pools. Not all must be active, but the common pattern is that people have a backup worker pool, configure the cluster autoscaler to work with priorities, and if a primary node pool is either maxed out or not available from an infrastructure perspective, then those secondary fallback node pools get active. If you have that for lots of worker configurations plus distributed across multiple zones, you easily get into several hundreds of worker node machine deployments and corresponding machine sets. All right, no demo for it. I wasn't able to prepare one timing-wise, but at least I hope this gives a little bit of context to this PR. And hopefully don't see those problems in the future.
Should we change these defaults in the MCM code also? What would you suggest? So,
to be honest, I don't know. I mean, well, how to put it? I don't know where else MCM might be used. As far as I understood, it would be it was designed to be rather generic, and if we're sure if it's always coupled to Gardener, then I would say it makes sense to raise the defaults to a certain degree. But yeah, hard to say.
I mean, those QPS and bursts were pretty conservatively chosen as the recommended QPS and burst when the MCM was originally designed to avoid excessive load on the API server. But I guess things have changed now. The API server is far more scalable than it used to be, so we can probably increase it by a bit, but probably not so high as it is mentioned here. I think this was done to so that when you have a large number of machine deployments and a large number of machine sets, this would help the processing faster for the MCM. Yes. So.
Yep. Yeah, I think increasing it makes sense. To which degree? Let's see. Okay, I saw more raised hands, I think. Maybe I was mistaken.
Of applause. Okay. Any further questions before we close the topic? Oh, all right. Then thanks for finding this out and tuning it. And with this, we are at the end for today. Thanks to all presenters. Thanks everybody for joining, and see you again in 2 weeks. Bye-bye.
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 See you.
Cool.